The Vikings did not have central heating. They did not have insulation bats, double-pane glass, or, programmable thermostats. What they had was a sophisticated intuition about the behavior of air, specifically that air is an extraordinarily effective insulator when you stop it from moving. The Norse longhouse was not warm because of the fire burning at its center. The fire was secondary. The structure was warm because every architectural decision made by the people who built it was oriented around a single principle. Trap the air and the air traps the heat for you. This distinction matters more than it might initially appear because it represents a fundamentally different theory of warmth than the one most modern households operate on. The modern approach is generative: produce heat, distribute it, and continuously replace the heat that the environment is constantly stealing from you. The Viking approach was containment. Create a thermal envelope that the cold cannot penetrate by controlling where air moves and where it cannot. A fire in a well-sealed room produces warmth that accumulates. The same fire in a drafty space produces warmth that disappears as fast as it is generated. The Vikings understood this through observation and built accordingly. The physics has not changed. The mechanism behind trapped air insulation is counterintuitive until you encounter it directly. Moving air carries heat with it. Convection is the process by which warm air rises, cool air replaces it, and heat is distributed and eventually lost to the environment. Still, air does not do this. A sealed pocket of air that is not circulating has no mechanism to transfer the heat it contains to the cold environment outside it. The warmth stays where it is. This is why the gap inside a double-pane window insulates. Not because glass is a good insulator, but because the still air trapped between the panes has nowhere to go and nothing to do except hold the temperature it contains. The Norse application of this principle was architectural, but the materials available today allow you to create the same trapped air geometry with far greater precision than timber and turf ever allowed. What the longhouse builders were attempting with packed earth and woven panels, a high-temperature ceramic fiber insulation baffle replicates with rigid, non-compressing geometry that does not settle, does not degrade, and does not lose its insulating structure over time. The 24 by 12 by 1 inch ceramic fiber blanket, baffle rated to 2,400 degrees Fahrenheit, is the material embodiment of this principle in a modern form. Not because you need it to handle forged temperatures, but because a material engineered for that kind of thermal resistance creates trapped air pockets that simply do not move. If you want to build the Viking heat trap system in a modern space, this is the material to start with. The link is in the description. The longhouse geometry also reveals something important about where trapped air pockets break down at the boundaries. A perfectly insulated wall is compromised entirely by a gap at its base, a poorly fitted frame, or any surface that allows convective air exchange between the warm interior pocket and the cold exterior. The warmth that accumulated inside the trap escapes through the weakest boundary point, and the rate of escape through that one point is far faster than the hours of accumulation required to build it. The Vikings sealed these boundary points with layered textiles hung at every entry threshold, not for decoration, not for privacy, but because each hanging created a secondary trapped air zone at every junction between inside and outside. Cold air could not enter freely. Warm air could not escape directly. The modern version of this boundary seal is a thermal blackout curtain, and the function is exactly the same even if the context looks different. A curtain hung floor to ceiling across a poorly insulated window is not decorating a room. It is creating a sealed dead air pocket between the glass and the interior, a zone that the window's cold surface cannot draw heat through as efficiently as it would with direct air contact. The Nicetown 100% blackout thermal curtain panels, 84-inch drop, black liner, 2 panels at 52 inches wide each, work this way. Floor length is not an aesthetic consideration here. It is a functional one. A curtain, stopping 2 inches above the floor, allows convective cold airflow at exactly the point where pooled cold air is most concentrated. The link to these is in the description, and if your windows are where your warmth is going, this is the boundary seal that stops it. What the Viking system reveals is that warmth is not primarily a generation problem. Generation is the easy part. Any heat source solves the generation problem. The hard part is retention. Every degree that escapes through an unmanaged boundary requires energy to replace. Every boundary that is properly sealed is a degree that stays in the system indefinitely, compounding with every other retained degree until the interior maintains a stable temperature at a fraction of the energy cost a leaking system requires. The cold air that cannot move cannot steal the warmth from a room that has been properly trapped. That was true in a Norse longhouse in the 9th century. It is equally true tonight. If you like this video, please leave a comment and a like for it to reach more audience. The product links are in the description. See you in the next one.